Hello guys, today we're going to study lesson 5.4 conditional probability. So far we have studied how to calculate simple probability of something to happen. For instance, let's consider here Cristiano Ronaldo, he's right-footed. So what is the probability, for instance, that he scores goals with his right foot? So of course, this is something that requires empirical probability, an experiment. And let's say that the number of right foot goals over the number of, the total number of clear chances Cristiano Ronaldo has had is, let's say, 55%. Okay, so the probability that he scores with his right foot is 55%, and the probability that he scores goals with his left foot is a little bit less, 35%. So this is just simple probability. You already know how to do this. All right. And we also moved on and learned how to expand this probability, this chance of one event or another event, just by calculating even that or the other one or both, right? So in this example down here, this is what would be the probability that Cristiano scores with his left foot or his right foot. So in this case, we need to apply the addition rule, correct? Which is the probability that Cristiano has to score with his left plus the probability Cristiano has of scoring with his right foot minus whatever probability there is in common. But here, these two are disjoint events because, of course, he cannot score with his both feet, right? So going back to the question, what is the probability that he has to score with his left foot or his right foot? It'll be what? It'll be 35% plus 55%, and so the total probability is 90. So the addition rule then definitely makes us expand the chance of one event to happen. Sometimes we have an event and we want to find the probability for such event to happen, but that event is conditioned, is affected by the fact that a previous event may have taken place. This is called conditional probability, right? So for example, what is the chance that, let's say, this team Barcelona wins knowing that Leo Messi, is going to play? Or perhaps, what's the probability that Barcelona wins a game knowing that Leo Messi will not play this time? So see, the probability that the Barcelona wins definitely gets affected by the fact this amazing guy will play or not, right? So in this example, because the event Barcelona winning may be affected by the first event, which is Lionel Messi playing or not, these two events are called dependent events. So here's the bottom line. Two events are dependent when the outcome of the first event influences the outcome of the second event. We can use conditional probability to calculate the chance of a dependent event to occur. When, for example, we are sampling without replacement. Let's suppose we have a bag, and the bag contains 2 blue marbles and 3 red marbles. So the original probability of choosing one blue marble out of this bag, it would be 2 out of 5, because there are simply 2 blue marbles and there are 5 marbles in total. So let's suppose that before picking one of these blue marbles, let's say somebody picked a red marble, right? So this is the first event. Somebody picked a red marble. So now, what would be then the new probability of choosing of randomly choosing a blue marble? So if someone picked one red marble, then the total, the sample space, is no longer 5. Of course, it's going to be 4, right? Now the new probability of choosing randomly a blue marble then is going to be 2 in 4, or 2 out of 4, which is 50%, and it was 2/5 before, right? Which was 40%. So the formula we can mathematically use to compute these probabilities, these conditional probabilities when sampling without replacement, is simply this one. Okay, notice this vertical line between B and A. B means this is the second event and A is the first event. So this is read this way: the probability of B, the conditional probability of B, given that or provided that or knowing that A occurred first, will be just a new fraction, right? Where the numerator is going to be simply a new number of times the second event can happen over the new total. So if you notice down here, this is the example we were talking about here. This is what would be the conditional probability to choose a blue marble, all right, knowing that a red marble was chosen first. So if we follow the formula, it was originally 2/5, but what's going to be the new numerator? Well, it remains intact, it's just 2, but the new total decreased from 5 to 4, so now the new probability then is 50%. Likewise, take a look at this example here. This is, what is the conditional probability of randomly choosing a blue marble, knowing that a blue marble was already chosen? Okay, so the new numerator, the new number of blue marbles will now be 1, because one blue marble was already chosen. There were 2, now there is 1. And of course the denominator also decreased by 1 because this blue marble was chosen out of the total. So the total probability, the new one, is now, the conditional probability then is 25%. When we use data tables, we will use a formula that is a little bit different. It's this one here, all right? What is the probability, the conditional probability of B, knowing that A occurred first? Well, that's going to be a fraction also, where the numerator is the probability of both events, B and A, over the probability of the first event. So let's take a look at this data table here. You know, there were 50 people in a meeting, let's say, and some of them had a bachelor's degree, some of them had a master's degree, and some of them had a PhD, right? There were 30 ladies and 20 gentlemen in all. All right. So for example, what is the probability of randomly choosing a lady out of this room? Okay, there were 50 people and 30 ladies, right? So it's 30 out of 50, that's 60%. All right. Let's review a little bit the addition rule. What is the probability of choosing a lady or someone with a PhD? All right, now we're going to expand the probability. See, the probability of choosing a lady was 60%, and now you see how this or word will increase because or is more. So this is the addition rule. The probability of choosing a lady plus the probability of choosing someone with a PhD minus the probability of choosing a lady and someone with a PhD, or in other words, a lady with a PhD. So then, of course, this is going to be 30 ladies, right, over 50, plus 3, only 3 persons here. 3 persons with PhD over 50 minus the common region, and the common region, which is here, it's 1, right? So if you add all these together, that's 32 over 50, which is 64%, and we knew it would be more than 60%. Now, let's now calculate the conditional probabilities of these two. For example, what is the conditional probability of choosing a lady at random, provided the fact that it already has a PhD? The person chosen, this is the condition, the person chosen has a PhD. So out of these person that have PhD, in other words, what is the probability of choosing a lady? All right, so that's pretty easy to see here in the data table, if you notice, guys, because there is only one lady with a PhD, so the probability is quickly 1/3, right? But if you apply this formula, you can also get it. Look, it's going to be the common region, the probability of the common region, which is 1 in 50, here 1 in 50, divided by the probability. It's always this event here that goes down here as a denominator. The probability of choosing someone with a PhD, which is 3/50. So when you apply double C, or you multiply the first fraction by the reciprocal of the second, in other words, to divide, you notice these two cancel, so it's 1/3. And we knew that, right? Now, let me illustrate this differently. What would be the probability of choosing someone with a PhD from all the ladies? That's another way to say it, right? And that's going to be 1/30, right? So let's apply the formula. The probability then of the common region will be 1 in 50, because it's PhD and ladies here, 1, right, over the probability of choosing a lady, which is 30 over 50. So applying double C, then you notice the 50 and 50 cancel, and it's 1 of 30. So notice that the probability decreased a lot. So finally, to end this video, we will simply mention here how to calculate the probability of 2 dependent events in a row, like one after another. And this is just a multiplication rule for dependent events. Alright? So the probability of 2 dependent events is going to always be the product of the first event times the probability of B after A occurred, or the probability of the second event, knowing that the first one occurred first, right? So I'm going to leave this question open for you. If that is true, if this multiplication rule works, then it should work for example, the probability of choosing a lady and a PhD and someone with PhD, which is 1/50. So the question is the probability of lady and PhD the same thing as this product rule, probability of lady times the conditional probability of choosing someone with a PhD, knowing it's a lady? So in other words, is 1/50 equals the same thing as 30 over 50 times 1/30? So there you go. So this is all we need to talk about for today's lesson. It's just these simple rules that we need to use in the classwork assignment. Good luck. Have a great day.